Nomenclature 2. Cyclic and bicyclic compounds. Have a look at what we've got here. It's got a cyclic portion with 6 carbons and an acyclic portion with 3 carbons. 3 carbons is prop, 6 carbons is hex, but since it's cyclic, it's cyclohex. Now, 6 is more than 3, so the cyclohex is the parent, and so we add ane to it. Since the propyl is a substituent, we make it end in YL. And then the name of this becomes propyl cyclohexane. You don't have to worry about a locant for the propyl because you will always number this to make the propyl on number 1. What about when you have 2 substituents? We have a propyl and an ethyl. We can number the propyl number 1 and the ethyl number 2 and go clockwise, or we can number the ethyl number 1 and the propyl number 2 and go counterclockwise. Either way, our locants will be 1 and 2. In this case, the tiebreaker consists of assigning the lower locant to the substituent that comes earlier in the alphabet. So our name then is 1-ethyl-2-propyl cyclohexane. No spaces anywhere in that name. Now here's an exercise for you to try. You're going to name this. Remember to first figure out what the parent is, then figure out the substituent, whatever numbering scheme gives you the lowest locants, and then assemble it alphabetically. Pause and work the problem. Once you've got the name, you can resume your video and check your answer against mine. Here's my answer. If we number the straight chain as the parent, it'll be heptane. If we number the cyclic portion as the parent, it'll be cyclopentane. 7 is more than 5, so the parent is heptane. As far as the substituents go, we've got a methyl, a chloro, and a cyclopentyl. So in numerical order, 2-methyl, 3-chloro, 4-cyclopentyl. As far as the locants go, numbering left to right gives us 2, 3, and 4. If we numbered right to left, we'd have 1, 2, 3, 4, 4, 5, and 6. 2, 3, 4 beats 4, 5, 6. So we're in good shape there. What remains is to assemble it alphabetically. CH should go first, then CY, then ME. So our name then is 3-chloro, 4-cyclopentyl, 2-methylheptane. Is that what you got? Good job. Now let's look at a bicyclic compound. Well, this is just cyclohexane. It's not bicyclic. But what if there was a CH2 group coming up towards us right here? And since it's coming towards us, we'll put it on a wedge. We'll make both of these bonds wedges. Like so. Another way to draw this is like this. this carbon that's coming up is this carbon right here. Now, how do we name it? Well, the name will be bicyclo, and then 3 numbers in brackets separated by a period, and then the name of the alkane that has that many carbons. So, how many carbons are there? 1, 2, 3, 4, 5, 6, 7. So it's going to be a heptane. It'll be bicyclo, bracket, A.B.C, heptane. What do A, B, and C represent? They represent the lengths of the bridges. What do I mean by bridges? Well, these are what we call the bridgehead carbons. If we go right, we have to go through 2 carbons to get from one bridgehead to the next. If we go left, we have to get through 2 carbons to get from one bridge to the next. And if we go up, we only have to go through 1 carbon to get through one bridge to the next. So the name of this parent chain is bicyclo, bracket, 2.2.1 heptane. And you always list them in descending order from the longest to the shortest. Say we had a substituent on here. Look, there's an isopropyl. So, this is going to be isopropyl 2.2.1 heptane. Oh, and I forgot the bicyclo. Isopropyl bicyclo 2.2.1 heptane. Now, this is a little bit ambiguous because we need a locant. So, how do we number this ring? Well, first of all, number 1 is always going to be one of the bridgehead carbons. And then you want to go through the longest ring first, or the longest bridge first. And you want to set it up so that you give the lowest locant to your substituent. Hence, we're going to call this number 1, this is 2, 3, 4, 5, 6, and 7. So, this becomes 2 isopropyl bicyclo 2,2,1 heptane. So again, remember, one of your 2 bridgehead carbons is number 1, and then you go through the longest bridge first. Here's an exercise. Draw 2-bromo-bicyclo 3.2.1 octane. Start with the parent. And then pause it and work it. Don't resume your video until you have your structure completely drawn. So here's the answer. The parent first. The bicyclo 3.2.1 octane. So we've got a 3-carbon bridge, and a 2-carbon bridge, and a 1-carbon bridge. Let's start off with the bridgehead carbons. Here's one, and here's one. There's a 3-carbon bridge. 1, 2, 3. There's a 2-carbon bridge. 1, 2. And then our 1-carbon bridge looks like that. And let's just redraw this line. yikes, in black, to show the gap. Now, where does the bromine go? Well, one of our bridgehead carbons has to be number 1, and then we go through the longest bridge first. So if we make this number 1, this is 2, this is 3, 4, 5, 6, 7, and 8. Which means that our bromine goes here.